So we're on now to 6.6, and we're going to be talking here about indirect proof. And the first thing to know about indirect proof is that in many ways it's similar to conditional proof, all right? So the learning curve here is not particularly steep if you're getting the hang of conditional proof. Having said all that, there will be some adjustments to make here when we're doing indirect proof. And so in fact, what I have right here is that we're going to start not in 6.6, but this is actually number 10 from 6.2, actually. So we're going to go back to 6.2, and then I'll explain how this relates to indirect proof in just a few minutes. This is actually a starred problem, so you can look it up in the back as well, but I want to go through the steps here to illustrate a point. We will remember that in 6.2, we don't have access to any of the replacement rules, right? So just remember that. We only have the 8 rules of inference here on this one. Having said that, doing this proof is just like all the other proofs. We look at the conclusion here, and we find it in the premises M, and as we can see here, the letter M does not appear in any of the premises. And so rather than having us panic as a result, right, we simply know that somewhere along the way here, we will be adding the letter M in, right, using addition. But we can also remember that we are guaranteed to use every premise we're given at least once before we get to our conclusion. So I'm not going to just, add the M right away. I'm going to do a few steps here if I can. And so when I'm thinking about doing a few steps, I'm going to look at my premises, see if I can get them to work together. And when I do, nothing's really coming to mind. I'm noticing that the letter D is in common here with 2 and 3 as well as 1 and 3. And so that seems to probably be significant. You may be thinking, since we're already covered the replacement rules, you might be thinking, oh, look, with 2 and 3 here, that looks very similar to the setup for modus tollens. But recognize that in order to do modus tollens with number 2 here, we would actually have to have, just right over here, scratch work, double tilde D, right? We'd have to have double tilde D to do modus tollens with that. While we can get D by itself through simplification in a minute here, while we can get D by itself, we can't actually add on 2 tildes to D because we don't have access to double negation in 6.2. So we're going to have to think of some other way to approach this one. Okay, nonetheless, let's at least simp, right? Simp is something we can do pretty easily. We have the left-hand side, the main operator is a dot, so we can pull it down pretty quickly here. Once we have D here, what are we going to do with it? Well, again, we're not going to be able to do modus tollens with line 2 because we don't have double tilde D here, and we can't get double tilde D in 6.2. We also, though, have a D in line 1. The only problem, of course, is that this D has a wedge E attached to it. So we might ask ourselves, well, is there some way to get the wedge E removed from line 1? And I hope that we can quickly dispense with that notion, right? Because there is no rule that will let you get wedge E and get it out of there. So rather than somehow surgically remove the wedge E from line 1, what we can do instead is add on, right? Add on the wedge E here to line 4. Now note, of course, that the E does not actually come from line 1, so we're not adding 1, 4. We're simply being inspired to add an E by line 1. And we want to add an E as opposed to any other letter here, of course, because once we have D wedge E, we can pair it with number 1, and that's just a straightforward, I hope, modus ponens. So modus ponens then gives us G dot H with 1, 1, and 5, right? G dot H, 1, and 5. Got G dot H there. That's good news, right? Because the main operator is the dot. We also want to pay attention to the fact that line 2 has not been used yet, right? So we want to keep that one in mind. And of course, line 2 and line 6 share a G in common, and so perhaps it would be a good idea to simp the G off of line 6, because now, right, just adjusting our focus here a little bit, we have in lines 2 and 7, P horseshoe Q and P. That's once again modus ponens. And so in line 8 here, we can get tilde D by modus ponens 2 and 7. tilde d. Great. So now we've used all of our premises, and always when you're doing these proofs, once you've used all of your premises, that's a good time to go back and ask yourself, what am I trying to get? Well, we're trying to get m, right? Well, that means, of course, we have to do addition. So now that we've used all of our premises, this is probably a good idea, or a good time, I should say, to add in the m. The question will be then, what should we add the m to? Well, recognize that when you add something on, you're going to add with a wedge, and since we want to get the m by itself, we're going to end up having to do disjunctive syllogism. So whatever we add the m to, we hope that we're going to have the negation of whatever it is we're adding the m onto, so we can then subsequently do disjunctive syllogism. In other words, watch what happens when we add on the m to line 4, right? When we add on the m to line 4, we get d wedge m. Now look at 8 and 9. That is exactly the setup for disjunctive syllogism. This is p wedge q and tilde p. And so we can get m by disjunctive syllogism 8 and 9. Okay. So I hope that all of these steps are making sense, and you can see how we can get m from these premises. At the same time, we need to recognize that there's something very strange going on in this proof, right? Because look at our premises, right? Our premises are talking about what? D, E, G, H, and F, whatever those stand for, right? Maybe it's about politics or sports or whatever. Talking about whatever they are talking about. But then from these premises, we are concluding something totally different, right? M, in other words, follows from this. That's very strange, right? How could we prove M to be true when it has nothing to do with these things? Well, what we can recognize is that the only way we're able to derive M from these premises is because along the way, these premises gave us D and not D, right? In other words, these premises imply that both D is true and, guess what? D is not true. That's how we get a very screwy, we might say, conclusion like M here, because these premises imply what we call a contradiction. Now, a contradiction is simply something, a dot, and then the same thing with a tilde in front of it. Okay, so A dot tilde A would be a contradiction. And anytime you get a contradiction, that is a sign that something has gone wrong in your thought process, right? It cannot both be true that D is the case and not D is true as well. And that is why we're able to derive things like M when really we shouldn't. You shouldn't be able to prove anything you want, even if you'd really like to be able to do that. So that brings us finally to indirect proof. And what indirect proof will entail is that we derive a contradiction from premises and an assumption that we're going to make. We're going to have to be able to derive a contradiction, which means we're going to have to be able to recognize a contradiction. So let's do this. What I've given you here are a list of things, and we can think about, well, which one of these things are contradictions? So looking at the first one here, A dot B dot tilde A dot B. That is a contradiction, right? It's something and then a dot, and the same thing with a tilde in front of it. So that is a contradiction. The second option, though, right, with A wedge B and so on, I hope we can all recognize that that is not a contradiction. If the tilde was on the other side of that parenthesis, it would be a contradiction, but as it's written there, that is not a contradiction. The third item here, A dot double tilde A, right? Well, we know from double negation in 6.3 that that's not a contradiction at all. In fact, that's more or less a way of repeating ourselves. The next one here, which is lining up right there, tilde A dot A, maybe I can do this. You can see my hand a little better. Tilde A dot A is a contradiction, right? It doesn't matter if the thing with the tilde is first or second. It's still a contradiction. The second to last example here, A dot tilde B, I have used that in my face-to-face version of this class more or less as a vision test, right? If anybody thinks that might be a contradiction, I encourage them to get their eyesight checked because, of course, A and B are different letters, so that's clearly not a contradiction. And finally here, in the last example, triple tilde A dot A, we might think, well, yeah, that's a contradiction, and in a certain sense it is, but just to be clear here, technically speaking, we would need to double negate the first piece here, so we end up with just single tilde A dot A as our contradiction, okay? So to do indirect proof, as we'll see when we do some proofs in the next video, to do indirect proof, you're going to have to be able to recognize a contradiction, and some of these are examples of that. Of course, some of them are not, but we'll put that into practice in the next video.